So my name is Lukasz, and this is Wojdan. We will be co-presenting this presentation. So basically, it's about the software platform that we are developing within a JANT project. So the JANT project is a R&D project funded by the European Union that is spanning multiple countries all over the Europe. And this is one of the outcomes of our work. So basically, we'll start off with some introduction to the nmaas platform, with including some technical details that might be interesting for you. Then we later on will showcase some main features and do a demo using a pre-recorded videos. We will showcase how this nmaas platform is applied to what we call a virtual network operations center in our context. We also will describe some new use cases that we foresee for the platform and how you can use nmaas and contribute to it. So basically, nmaas is an open source platform that can be used for orchestrating deployment of applications in the cloud environment. So in our case, the underlying cloud environment is based on Kubernetes, which was quite new when we started our journey, but for sure by now it's very commonly used and very popular. So it's a multi-tenant architecture, meaning that one nmaas instance can serve multiple users grouped in what we call a domain. So the platform supports a very simple application deployment and upgrade process using the web-based portal that we have developed from scratch as well. And let's say the core of the platform is also a catalog of applications that can be deployed through the portal, and those applications can be simply added to the catalog with not that much effort. We also include some GitOps approach operations that are used for application configuration upgrades once the application is already running. We also integrate some log viewing within the portal that can be used for application instance troubleshooting if some issues arise. But basically, most important thing is that the software is open sourced, and then there's free access to it. So basically, along the way, we have identified that such a platform that was originally meant to be a network management as a service solution offered to other participants of the project and R&D and education institutions across Europe can be used in other contexts as well. So currently, we are supporting two the so-called use cases. One is the virtual NOG that we are going to discuss today, and the other one is, for example, virtual lab, meaning the online hands-on exercises organized using nmaas in an educational context, where users, students can have access to applications running in the cloud, supporting their laboratories and the exercises that they need to execute. And for those two use cases, we have a dedicated instances running. Those instances of nmaas are operated by a dedicated team within the project, and this is what we call managed instances. So basically, why to use nmaas for virtual NOG? So basically, as mentioned, the application deployment process is very straightforward. So using the portal, you can just click a new and the new application selected from the portal is being deployed within minutes. Also, the initial configuration and the configuration during runtime is also made easy for the users using the so-called configuration wizards, and this also Git-based approach that will be later on showcased as well. We support multi-tenancy as mentioned, so a single nmaas instance running in on top of the Kubernetes cluster can be used to manage multiple infrastructures, specifically also by different teams that have been granted dedicated isolated environments within the platform, so they do not overlap with each other. And of course, in case of managed instances, all the applications are being deployed in the central cloud that is provided by the project, and also it is operated by the project itself. And of course, then what is important, users can only focus on setting up the applications to monitor the services or infrastructure they have to, but they don't need to focus on maintaining the applications themselves, or even maintaining the infrastructure on top of which the applications are being run. So initially, for BalticNOG, the target users were national research and education networks and institutions like universities, high schools, and others that might not have the either the main power or the resources to run some nmaas systems on premise, and also some other teams, research projects or development teams that have to deal with some kind of monitoring of some assets, but might not have the resources to set it up. In this case, you can use the open service running in the central cloud to set up monitoring, for example, some health checks and alerting within minutes using nmaas. Yes, so the catalog already contains a lot of network management applications, very popular ones. It will be showcased as well. We are still working on adding new features and improvements to the platform. And on the right, you can see how nmaas is overall deployed. So we have some components running in the central cloud. So nmaas is deployed there along with all the applications deployed through nmaas. We have some networking set up towards the infrastructures that are to be monitored with nmaas. But we'll get into details in a sec. So here are some examples of the current users of the BalticNOG service. For example, PCSS in our case, so we use it to monitor some laboratory equipment that we have built and offered to our users in Poland. And also we have some services exposed that we have developed in different projects, but we use nmaas to monitor them and do health checks and database backups. So some technical insight regarding this. So we are, of course, on top of Kubernetes, we are deploying containerized applications. Each application is represented as a Helm chart, what makes it easier for the overall application deployment process. And of course, new applications can be easily added to the catalog, since nowadays Helm charts exist for all the applications basically. Yeah, so also using Helm and its features, we are able to introduce this customization that allows users to during deployment time, allows users to pre-configure a given application instance with some initial configuration that allows to set up monitoring or initial user accounts or whatever right away. Of course, this using Helm also allows us to do some application upgrades easily triggered from the nmaas platform. Considering some networking aspects, in this case, we need to make sure that the applications running within the central Kubernetes cluster can reach the resources that they monitor that might be, in most cases, some remote networks or remote infrastructures. And also we need to make sure that users of the applications have secure access to the user interfaces of those applications that they have deployed, that no one else have access to them. over the internet. So to this end, we have developed solutions for, applied solutions for so what we call a site-to-site VPNs, meaning the connections between the applications running within the cluster and the infrastructure that is being monitored. We are using WireGuard in this case. And for the client access VPN, we are using EduVPN software that was also developed within the Jean project that is compatible both with OpenVPN and WireGuard. For our managed instances, we are supporting dual stack, both IPv4 and IPv6. Also, users the applications deployed by users are exposed under dedicated subdomain to access the UI. Regarding multi-tenancy, we have introduced a concept of domains. This ensures isolation between the applications being deployed by multiple users of the platform. We have the portal has a support for OpenID Connect login, or users can also opt to use local authentication. Also, integration with EduGain is possible in case of our central nmaas instances. We also recently added support for webhooks that can be used to further integrate with third-party systems to execute some actions based on the events that took place within the nmaas platform. Okay, maybe I'll now give the floor to Wojtek.
Thank you, Lukasz. So Lukasz showed us what nmaas is and how it works in theory. Now let's see how nmaas works in practice. So as mentioned previously, nmaas supports an extensible application catalog. Currently, regarding the virtual NOC use case, we support more than 27 applications, mainly targeted at network management and network monitoring. So if we need to highlight some of the most relevant features for the virtual NOC use case, these for sure would be the application deployment wizard, which allows us to customize the application during the deployment time so that it reflects the environment that we would like to monitor. Then the GitOps configuration, which allows us to reconfigure the application during its runtime by just editing configuration-based, text-based configuration files and then committing them to a Git repository. And then nmaas does all the work of syncing these changes to the running instance in the cluster. For easy troubleshooting and debugging, we also support live application log viewing. And of course, we support continuous upgrades of the applications as updates are available. So these updates can either be automatic, or once a new version is available, the domain administrator can choose at what point the update will be applied, so to minimize downtime. So in practice, we will show two demos. The first one is the application deployment. This is the nmaas landing page, and we will be logging in as a demo account. After the initial login, we are presented with a message that we haven't associated an SSH public key with our account, which will prevent us from doing any Git manipulation. So this is the list of available applications. We'll first take care of that warning about the SSH key. So we'll be adding a public key to our account. Any existing or new public key that you generate can be used for this purpose. After adding this key to your account, you will gain full access to the GitOps configuration features, which we'll look at shortly. From the catalog, there are a lot of applications, but as one of the most popular ones, we will choose Prometheus. And in this case, we will have a very descriptive name of Prometheus for the instance. And we will select an older version on purpose as to be able to upgrade it later and to be able to see the upgrade functionality in practice. This is the customizable per application wizard that we have mentioned. So in this case, we can add Prometheus targets directly during deployment time using the nmaas interface. After a few brief moments, once we have submitted our desired configuration, the application should be ready to be accessed. And we can see in the Actions menu both Access and Configure buttons. If we click on the Access, we are provided with information on how to access this application both externally, so from our workstation, but also from other applications in the cluster. If we go into Status and Targets, just to verify that our initial configuration has been correctly applied, we do see that yes, the loopback address and on port 9001 has been added as a target. What if we want to add more targets, or if we want to change the configuration? Well, this is where the GitOps configuration comes in to play. We'll be issuing the git clone command on the CLI. This git SSH command variable at the front just allows us to use a separate SSH key, so it's not of no concern. Once we clone the repository, we can just open our favorite text editor and the configuration will be right there. This is the initial configuration that was generated by nmaas for us during deployment. We can append or delete any configuration. We'll be adding a new target here. And after we make changes to the configuration, we can apply these changes just by committing and then pushing to the remote repository. And that's all there is to it. At this point, nmaas will automatically in the background see that there is a new version of the configuration available, and it will apply this configuration. Depending on the application itself, the application might need to be restarted, or there can be a soft restart, so without termination of the container behind the scenes. Prometheus supports live configuration reloads, so the container doesn't need to be explicitly restarted. We saw that the new target was indeed available in the web interface. If we go into the application list, we can see that there is an update available for Prometheus. At any point in time, we can just do the upgrade, of course, preserving all user data. After a few brief moments, the application will, of course, be restarted and it will be running the new Prometheus version in this case. If we go to the web interface, we can indeed check that the upgrade was successful. Yes, the version is the latest version available at the time of recording. So this was how a single application can be deployed and configured and reconfigured on top of nmaas. But of course, Prometheus by itself is not very useful. You would like to visualize the metrics that you have acquired. For this, we also support, for example, Grafana. And this is how multiple applications together can be combined to create a network monitoring system, a network alerting system. So in the case of Grafana, we have a different configuration wizard because Grafana requires different parameters during its deployment. In this case, we also have the flexibility to decide whether we would like to immediately connect Grafana to an existing Prometheus instance or not. In this case, because we already have a Prometheus instance on nmaas, we can just select it from the drop-down menu. After a few brief moments again, the application will become accessible for us and we will be able to see the deployment parameters and of course access the application. We can log in with the credentials that we have specified. And now if we go into the configuration and choose the data sources panel, we will see that the previously deployed Prometheus is automatically added as a data source. So no additional manual intervention is needed. nmaas is aware of the instances that you already have. So because we have Prometheus as a data source, we can just import some dashboard to see whether the connection really works in practice. We'll be importing the popular node exporter dashboard, and we can see that the metrics acquired from one of the targets that we have configured on Prometheus can indeed be visualized now by Grafana. And this can be extended with additional tools. So for example, we can connect Alert Manager for sending alerts and so on and so forth. So basically, use these applications like Lego bricks to build up your system, which will run on top of nmaas. So everything that we have presented so far, of course, is deployable on a single cluster, the cluster where nmaas is running. The question now is, well, can I deploy these applications, so use the same application catalog, but to do the deployments on a remote cluster. And this is basically the new use case that we have envisioned for nmaas, called nmaas federations, where the nmaas platform can at the same time deploy applications on multiple remote Kubernetes clusters. And in this case, basically, this solves the problem of managing many diverse environments individually. So looking at each environment as a separate silo. And you have a reusable application catalog, which you can keep up to date and then do the upgrades from this central place. All of the features which are meant to be part of this new use case will be part of the base software, which is, of course, open source. The main benefits of this new use case are basically that we enable a bring your own infrastructure type of scenario. So you provide the infrastructure and nmaas provides the lifecycle management and the application catalog. And because everything runs on premise, you have full control over your data, and there's no longer need for complex site-to-site VPN connectivity because the applications are hosted within your network. And there's also no need for complex client access strategies. Your employees can use any existing VPN solution in place. This completely abstracts away the fact that there are multiple Kubernetes clusters hosted at different locations. The users and even the administrators, the only thing that they see is the nmaas UI. One application where this can be used in practice and what we are piloting as we speak is basically to create a toolbox of network monitoring applications which can be deployed in a federated fashion across different sites. And using these deployments, you can monitor network health in a distributed manner. In the future, we also want to explore how we can not only deploy the applications themselves on these remote clusters, but also how to, as easily as possible, deploy the clusters themselves to bootstrap the remote infrastructure. So to deploy Kubernetes and then onboard the clusters to nmaas. Lukasz, back to you.
Okay, thank you. So I will just take over for a few brief slides. So basically, just a few information about how you can actually get your hands on nmaas and how to use it. And there are a few options. So one option, of course, is to deploy nmaas on your own infrastructure, and this is what we call a self-hosted way of using nmaas. And of course, the other way is to use one of our managed instances. In this case, in order to be able to use a VNOG instance, one should fill out the form available on the portal to provide some information that we can do the admission to the platform. As it goes for the self-hosting options, we provide some instructions on our documentation page and docs.nmaas.eu. You can either set up a local environment on your local PC, or if you have a full-fledged Kubernetes cluster running at your infrastructure, for example, on-premise, then you can set up nmaas on top. Just a few words on the conclusions. Okay, so what we are currently working on and what are the future plans. So basically, we have recently released version 1.8.0 of nmaas that comes with a completely redesigned UI. These already mentioned webhook support and some initial version of this multi-cluster support that was mentioned by Wojdan just a second ago. Of course, we keep adding new applications to the catalog that we find that might be potentially useful and attractive to some potential or existing users of the platform to allow more use cases from the user perspective. And also on our end, we are also actively working on proposing new use cases for the nmaas platform. Also, like to hear from any user or any potential user on how nmaas could be used in different contexts. And we also plan to refine this multi-cluster support, since this is our current main focus. So nmaas is a versatile orchestration platform based on popular technologies. It's open source under the Apache 2.0 license, and especially in the context of this presentation, it is very much suitable for running a cloud-based nmaas. Of course, we are all welcome to hear any ideas, suggestions from your side regarding missing features of applications or any new use case proposal. And yeah, here are just some means to contact us. We have recently set up an nmaas LinkedIn group, so we are all you are all invited to join it and to hear and stay up to date with all the nmaas related news. Thank you.